Hello, everyone. First of all, I would like to apologize because I cannot attend to the symposium, and we have found the solutions to record this presentation, and I'm very pleased to share with you the interest of Solvay in the IGC, which is a versatile tool for the surface characterization. So first of all, concerning our lab, it is a joint research center between Solvay, the CNRS, and the University of Bordeaux. It is located near Bordeaux, and our main mission is to accelerate innovation and support business units in their research. And for that, we use a robotic platform to make some parallelized experiments, and we have some robotic platform dedicated to the synthesis and for the formulation. And the other axis we are working on in the use of micromillifluidics to make continuous reaction. As you can see on this figure, we can generate some droplets corresponding to different microreactors and different type of experiments. So we can generate a lot of experiments like this. We have different scientific profiles in the lab: physicists, chemists, physical chemists, data scientists, and automation and IoT engineers. And the main topic we are dealing with is around the physical chemistry with solubility dispersion issues, rheology, wet chemistry, surface chemistry. And we try to develop online analysis and try to automate our experiments. In the last years, we try to develop also some tools for the machine learning and extract more and more information on our experiment. So now, this is a key point for Solvay to understand the surface and interface chemistry, because we can produce a lot of inorganic particles like silica used in tires to reduce rolling resistance. And you can find also some silica in your toothpaste for its polishing and thickening properties. And in all cases, we need to investigate to understand the interaction between the material, silica, and the elastomer and the tire ingredients. And also for oral care, the interaction between the teeth surface and the toothpaste ingredients with the silica. Concerning the production of rare earth oxide, it is used for the catalytic support in automotive depollution and also in semiconductor polishing. And once again, we need to investigate the interaction between oxide and pollutants and oxide and silicon wafer. And finally, we also have some activities around surfactant, dispersing agent, and adhesion promoters used to pigment dispersant in paints, additive for metal paint adhesion, and surfactant for enhanced oil recovery. And in all cases, we need to investigate interaction between the ingredients. So I would like to share with you different cases of study around the silica for tire and for the different activity around additive for metal paint adhesion and the surfactant used in enhanced oil recovery. Concerning the equipment we have, it's come from the scientist company. We can simultaneously analyze two types of materials, and we have an auto sampler allowing a very good reproducibility in terms of injection, and we accelerate also the quantity of experiment with this tool. We mainly use the IGC in the infinite dilution configuration, and we determine the surface energy, the specific index, the Ka and Kb, and also the morphology index. So concerning the meaning of a surface energy, for a chemist, it can be very difficult to explain the meaning of surface energy. And when we look at the definition of dispersive component surface energy, is essentially due to the van der Waals interaction and mainly the London force. And it is correlated, it is function of the polarizability of your molecules. In the case of the oxide, we have experimentally determined the surface energy for different kinds of materials like silica, alumina, ceria, zirconia, as you can see here. And when we compare with values of electronic polarizability extract from literature, you can see a pretty good agreement between these two values, and it can be a good general approximation to predict the surface energy. But sometimes, here, for instance, in the case of silica, when we try to adjust the synthesis parameter or try to functionalize the silica, the surface energy can be very affected, as you can see here in this value. And so we need to understand why. So concerning the case of precipitated silica for tire, and especially in the case of a process optimization of silica synthesis, after the precipitation of silica, we use a filter press to remove the high amount of water, and we add some additive at the surface to facilitate the deconsolidation of a silica cake. And here the goal is to explain the optimal amount of additive by IGC. For that, we have compared two types of silica, and we have modified the quantity of additive at the surface. And here, with the red points, you can see the amount used in the process. And when we determine the surface energy and morphology index, as you can see here, we have a maximum value corresponding to the amount used in the process. So it's very consistent with the application. And when we see the value of surface energy, we tend to decrease the surface energy when we increase the amount of additive. So we have an optimal interaction between the additive and the silica for this amount of additive. And when we increase this amount of additive, we tend to make some cluster of this additive and generate some heterogeneity at the surface. Concerning the morphology index, as you can see here, we have a decrease of the morphology index for the silica one, and is pretty in good agreement also with the textural properties of the silica compared to the silica 2, exhibiting a higher micro and mesoporosity. So also the IGC is very useful to the study of aging, because silica can be also affected by different conditions in terms of humidity and temperature. And in this case, the idea was to classify silicas according to their stabilities. Once again, we have compared 3 types of silica and perform an aging during 24 hours in this condition of humidity and temperature. And concerning the surface energy, as you can see here, we are able to differentiate the type of silica just with the surface energy. And once again, it's very consistent with the textural properties of the silica. And concerning the morphology index, as you can see here, this is very interesting because we are able to see the accessibility is modified during the aging, and especially for the silica free. As you can see here, we have a strong decrease of the morphology index, meaning that we have lower accessibility compared to the other type of silica. Now, another study concerning the salinization of a silica used to improve the compatibility with rubber. It's well known in the literature, this kind of study, and we use also at Solvay to try to compare the different type of silane at the surface and see the effect on the surface energy, Ka and Kb, and also morphology index. And we try to correlate with the surface energy estimated for elastomer to see if we have some compatibility with this kind of materials. Now, another topic concerning the paint coating on metal. Solvay offers a solution to improve adhesion and corrosion resistance between the metal and paint by using organic additives, but generally the surface characterization of metal surface can be very time consuming and need to use a lot of advanced tools. And for that, we have the idea to use IGC to see if it's relevant or not for this application. So organic additive is the adhesion promoters. It makes the links between the powder paint and the aluminum and the oxide layer at the surface. And the idea here is to try to understand the interaction between the organic additive with the oxide layer. So for that, we put aluminum oxide in powder and absorb some different amount of organic additive and measure the surface energy gamma plus and gamma minus. And we perform the same thing for the powder paints. And we can also try to estimate the work of adhesion by using these two equations with a dispersive component here and a polar component. And we can try to predict this adhesion with this equation. So here is the result, as you can see here on this slide. As you can see, when we have some additive at the surface on the aluminum oxide, you tend to increase the surface energy of the materials and tend also to decrease the gamma minus, which is correlated with the basicity of your material. So you have interaction between the hydroxy groups of aluminum oxide with the additive, and it depends obviously of the kind of the type of additive adsorbed at the surface. We have measured also the surface energy and gamma plus and gamma minus for the epoxy paint. As you can see here, the value are lower compared to aluminum oxide. And we can estimate with these values here in the tables the work of adhesions and compare different additives. As you can see here, we can see an increase of the work of adhesion when we have some additive at the surface. So it's very consistent also with application test, and especially with mechanical adhesion test, we see a better performance when we have the additive. This is the goal of the additive. And finally, I would like to present also some studies, some works about the surfactants used for enhanced oil recovery. The surfactants are added to improve oil extraction and reduce the oil-water interfacial tension, but sometimes they can also interact with the rocks, with the surface of the rocks. And to try to investigate the interaction between surfactant and rocks, we make some adsorption isotherms in different conditions by using sodium chloride solution or seawater, and put different type of minerals we can find in the oil reservoirs like clays or feldspat. And after that, we stir during 24 hours, we centrifugate and dry the powders, and analyze the powders by different analytical techniques like infrared spectroscopy, TGA, DSC, and also inverse gas chromatography. So concerning the result for inverse gas chromatography, in the case of monomer unit plus surfactant, we have measured the surface energy and morphology index. And as you can see here, the surface energy is very high at the beginning on the pristine monomer unit. But when you adsorb some blend of surfactant at the surface of the monomer unit in different conditions, in seawater or in sodium chloride, you can see a strong decrease of the surface energy. And concerning the morphology index, inversely, you have a strong increase of a morphology index value. We can explain that with at the beginning, we have a layered structure of a monomer unit with a low accessibility, as you can see in this illustration. And when we put some blend of surfactant, we have a strong adsorption with a layer of memory unit, and you increase the distance between layer and increase also the accessibility for the different probe we have used for the estimation of morphology index. So it's very useful and interesting to estimate the different aspects concerning the surface properties and modification of the morphology. So to conclude, I would like to say that IGC is a very powerful and quantitative technique and help us to better understand the surface chemistry of the oxide. But sometimes interpretation of surface energy can be very difficult, and for that we need to compare with other techniques like zeta potential, Carl Fisher titration, or infrared Raman spectroscopy to facilitate the interpretation. So I would like also to thank all contributors of this presentation, the student, PhD students, interns, short-term contract, and also the business unit, and also at scientists for their scientific support and their reactivity to solve problems when we have some troubles with the equipment. So thank you for all of these contributors. And thank you also for your attention. And if you have any questions, don't hesitate to contact me. And I will be very pleased to answer to your question. Thank you.